Hello, welcome back. In this video, I'm going to be going over 3 ACT math questions. For all these problems, I recommend pausing the video and trying the problems yourself first before you see me solve them. Without wasting any time, let's get into it. So, question 14 says, what is the largest possible product for two even integers whose sum is 50? So, let's call our first integer x, and let's call our second integer y. Okay, so let's just start off with like random numbers first to just see what product we get. Okay, so let's start off with like, for the first integer, let's start off with 2, okay? And that would mean the second integer would have to be like 48. And if you took the product of these two numbers, you would get 96, right? So this matches answer choice F, but this is just like one combination. There's so many other integers that could add up to 50, right? And this is actually not the greatest possible product. So let's just keep testing. Let's go with 44. Let's make the first integer bigger this time. And the second integer is going to be 6. And the product of 44 and 6, that is 264. So clearly you can see that 96 is not the largest possible product for two even integers that add up to 50. It can be even greater. So now with 44 and 6, you get 264. But let's keep testing with more and more different integers. Let's go to 38 and 12. And let me figure out the product using a calculator. 38 times 12 is 456. Okay, so here's the idea I want you guys to understand. We started off with, for the first integer, we started off with 2, and the second integer was 48. Then we went with the first integer being 44, and the second integer was 6. Then we made the first integer 38, the second integer was 12. But the thing to realize here is that the product of this was 96, the product of this was 264, and the product of this was 456, right? As the gap between the integers, as they keep getting closer to each other, the product keeps increasing. So the thing to realize in this problem and understand is that you want to basically get these integers as close to each other as possible in order to maximize the product of these two integers, which is x times y, right? We call the first integer x, and we call the second integer y. X times y is just xy, right? And we want to maximize x times y. So you would want to get them as close to each other as possible while making sure they have a sum of 50 and they're two even integers. Because if you were to for example, if we were to maximize like x, right? The greatest value of x would be 48, but that makes y very small, which is 2. If we make y very big, like 44, that would result in x becoming smaller. So if they're close to each other, then you're going to make them still relatively big, and you're going to get the largest product possible. So you want these to be as close to each other as possible. So let's just test integers that are very close to each other. So let's go with like 28 and 22. 28 times 22 is 616. if we look at our answer choices, that doesn't match anything. So that means we could probably go even closer. Now let's test 26 and 24. And this is the closest you can get. 26 times 24 is 624, which matches answer choice 14. So for this problem, just remember to try to get the two integers as close to each other as possible in order to maximize the product. On to the next question, question 39, which says, what is the value of this big fraction? And we're given our answer choices. Okay, when you see this type of problem, don't panic and be like, what the heck do I do? But let's just break this down and simplify this. So basically, we have 1 over all of this, right? 1 over a denominator, right? And we don't know what the denominator is right now. It's just all of this. So we would want to simplify all of this, right, into one number. So let's go down a step. Let's just look at this. Let's just look at the denominator. It's 1 plus 1 over all of this, right? So that means we should probably simplify this first, and then we'd want to simplify this first. So whenever you just see like a lot of fractions inside of a big fraction, right? Just always start from the bottom and make your way up, and then you would be able to get a simplified number for the denominator, and then it will all become easy. So start from here and then make your way up. So 1 plus 1/3. Let's start here. 1 plus 1/3 is 4/3, because 1 can be rewritten as 3 over 3. 3 over 3 plus 1/3 is 4 over 3. So we're just simplifying this part right now. So it's going to be 1 plus 1 over 4 over 3, which is 1 plus 3 over 4, right? Because 1 over 4 over 3 is just 3 over 4. And then 4 over 4 plus 3 over 4. 1 can be rewritten as 4 over 4. You get 7 over 4. So we just simplified this bottom part here. So now we can rewrite it as 1 over 1 plus 1 over 7 over 4. Oh, it's glitching. 7 over 4, right? So again, just remember to simplify from the bottom and just make your way up. Now, 1 over 7 over 4, that is just 4 over 7. You're just taking the reciprocal. 1 over 1 plus 4 over 7. 1 can be rewritten as 7 over 7. 7 over 7 plus 4 over 7, all over 1. 1 over 7 over 7 plus 4 over 7. That gets you 1 over 11 over 7. And if you take the reciprocal of this, you get 7 over 11, which matches answer choice C. So just remember to simplify from the bottom and make your way up. All right, on to question 56, which says, how many seating arrangements are possible for 5 people to sit in the 5 seats of a car if one person sits in each seat and only 3 of the 5 people can sit in the driver's seat? So for this question, let's first draw 5 blanks to represent this 5 seats. 1, 2, 3, 4, 5. Okay. And let's call the first blank or slot the driver's seat. So this is your driver's seat, all right? So remember, the problem says that only 3 of the 5 people can sit in the driver's seat, right? Which means the amount of possibilities here, or the amount of people that can sit in the seat, are 3. So there's 3 possibilities, right? 3 choices. So that means now let's move on to the other 4 seats, right? So the second seat. So how many people can sit in the second seat? How many possibilities slash choices are possible in the second seat? If you say 5, you're close. But remember that one person out of the 3 is going to sit in this seat, right? Which means there's only going to be 4 people left. So this has to be, there's 4 choices because one person is going to sit here. So 4 people are going to be left, which means only 4 people can, there's 4 choices for this seat. For the third seat, there would be 3 choices or possibilities, right? Because one person sits in this seat, one person sits in this seat. And it's 3 because one person sits in each seat. There's no repetition. Same logic. This would be 2 choices as there's 3 people sitting in the first 3 seats and there's only 2 people left. And then finally, the last seat, there's only going to be 1 choice. Now, you just multiply the possibilities. So 3 times 4 is 12. 3 times 2 is 6. 12 times 6 times 1. 12 times 6 is 72. So there are 72 possibilities or seating arrangements, which matches answer choice J. Yeah, thank you for watching, and I hope these explanations made sense, and I'll see you guys in the next one.